it says a 62 kilogram person on skis is going down a hill sloped at 37 degrees. The coefficient of kinetic friction between the skis and the snow is 0.15. How fast is the skier going 5 seconds after starting from rest? Understood? Okay. So we got to do all this stuff. Okay. We'll use 10 for gravity. So this will be 620 newtons. Okay. And then what is 620 cosine 37? 620 cosine 37.
495.
495.
Exactly.
What is 620 sine 37? 620 sine 37.
337.
337?
No, 373.
Say what?
373.
373.
Yes, sorry, my bad.
Okay, good. What is the equation for friction? I know that Ff over Fn equals mu. Okay?
Okay.
So Ff is mu Fn. Right?
That's right, yeah.
So what is 0.15 times 495?
That is 74.225.
74.2?
Yes, basically.
Is that okay?
Yep.
74.2. Right? So, now, I have two forces acting against each other, correct? I have 373 going down,
Yes.
correct?
Yep, that's right.
And then
74.
going up,
74.2.
I have, going
74.
up, I have
74.2.
74.2, right?
Yes.
Right? So they're contrary forces.
Exactly. That's
So what's the net force? So what's my net force?
Net force.
What's my net force?
So 373
373 minus 74.2.
Which is 298.8. 298.8.
No. 298?
Yes. But yeah, 298.
I didn't hear what you said.
298.
Oh, 200. Oh, I thought you said 288.
No, 298.
So my net force is 298.
That's
Is
right.
that enough? Is that okay?
Yep, that's right.
Okay. 298. Right?
Yes.
So, if I push on a cart with a net force of 100 newtons, I'm going to accelerate that cart, right? In chapter 6. How much is it going to accelerate? What's it dependent upon?
It's depending on the force. So
It's dependent on the force that I'm applying. And what about that cart? It's dependent upon chapter 3, inertia, the resistance to change. Do you know what resistance to change is called? Inertia. What else is it? What is it? But inertia is too serious a word, dude. What is, listen carefully. You've all been in a store where you have a shopping cart, correct? And I want to accelerate that cart. I want to run crazy down the aisle.
Black Friday.
What is, and I'm going to accelerate that cart, correct? I'm going to accelerate that cart by applying a force. That makes perfect sense, right? But what's resisting me accelerating that cart? What's the resistance to the change? What's the resistance? What's resisting it? It's the inertia.
Exactly.
Is there another word for inertia that you could think of? It's called mass. You ever hear of mass?
Yes, of course.
Mass is actually the resistance to change. Mass is really another word for inertia. So this, that equation is chapter 6. It's huge. That means that the force I use to accelerate an object is dependent upon the mass, which is resisting the change, correct?
Yes.
What's inertia? Inertia is a body at rest, a body at rest, a mass at rest, a mass at rest, a body, a mass at rest. If it's at rest, it's going to stay at rest. That mass is going to stay there unless acted upon by an external force. That cart in the store is going to stay parked up front unless you apply an external force. You're the external force. Clear?
Yeah.
A body at rest will remain at rest unless acted upon by an external force. A body in motion in outer space will remain in motion forever unless acted upon by an external force. So this body is what you're talking about. That mass will remain at rest or remain in motion unless acted upon by a net force, a net external force. If the forces are equal, then you're not going to get acceleration. You'll get a constant velocity. Okay? Now, so what's this, the skier's going to accelerate, isn't he?
Yes.
He's going to accelerate. How much is he going to accelerate? Well, let's solve it. Acceleration equals the net force divided by the mass. I know the net force to be 298 newtons, right?
True.
Yes?
Yes.
What's the mass? Go back to the original problem, right up there. 62. So what is 298 divided by 62? 298 divided by 62 is what?
4.8.
4.8. So the acceleration is 4.8 meters per second squared. So, is this coming up? Can you see this on the?
Yeah. Yes.
Okay.
Yes.
So, I know that acceleration equals velocity over time, correct?
Yes.
Yes? I know my acceleration. And I know my time. My time is 5 seconds. Because it says, given this whole setup, how fast is he going to be going from rest after 5 seconds? Okay? So velocity, V equals AT. Right? So A is 4.8. T,
Which is 5 seconds.
5 seconds. So what is 4.8 times 5?
24. Done.
What is it?
24.
Wow. 24?
24.
Yes.
Done. 24. 1 meters per second.
So he's going to be moving. He's going to be going 24 meters per second. Boom. Shushma.